So, it was a now it's on project. Okay, so the last class, which question we answered? Remember?
Yes, seven.
7. Okay. So let's try number 8, please. Let's try number 8 question, please. By using ratio test, just check this series converges or diverges, please. Question number 8. Sigma 1 to infinity. Question number 8, please. Sigma n equal to 1 to infinity. Then we have n times 5 power n. And 5 power n divided by 2n plus 3, 2n plus 3 into ln with the argument n plus 1.
Yes.
ln with the argument n plus 1. Okay. So please, by using ratio test, just confirm, check, converge or diverge, please. So I already discussed in the last class the calculation rules. I already discussed how to calculate. What is the calculation formula? And what are the rules when converge, when diverge, already. So what is the rules for ratio test?
It's greater than one.
Greater than 1.
It's
If
converge.
answer of the calculation greater than 1,
Diverge.
diverge. If
Less than.
answer the calculation less than 1,
Converges.
equal to 1,
No.
there is no basically availability of option equal to 1, please. So please, first of all, calculate here a sub n plus 1. The question is a sub n, okay? This is a sub n. So kindly calculate a sub n plus 1, and I told you for a sub n plus 1, replace n by n plus 1, okay? So wherever you have n, it should be replaced by n plus 1. So this is n replaced by n plus 1, please. 5 has n power, become n plus 1 now, because we are calculating now a sub n plus 1 term. Divide by, this is 2 times now n, and replace by n plus 1, please. Then plus 3 is already here.
And
Then we have ln function. It has argument s, which is replaced by n plus 1, and plus 1 in the last one. Before you go for the calculation formula, just make it one more time simplified, please. Means you can write n plus 1, 9. Okay, 5 power n plus 1.
5 and
Can I break?
times 5 power.
Yes, power 1. So power 1, don't write no need. Divide by 2n plus 2 and plus 3. So 2n plus 5.
Yes.
Yes or no?
Yes. And m plus 1.
2.
And plus 2.
Yeah, because 2n and plus 2 and then plus 3 becomes 2n plus 5. Okay, from here 2 plus 3 becomes 5. Understand how to get 2n plus 5?
Yes.
Then plus 1 plus 1.
Plus 2. Plus 2.
So it is n with the argument
And
and plus 2. So basically this is your a sub n plus 1 term. Understand? How to calculate the a sub n plus 1? It's not any difficult thing. In the question, wherever you have n replaced by n plus 1, then you can simplify forward. Okay? Right. Now you can apply the formula of calculation, please. So the formula is that limit n approaches to infinity. This a sub n plus 1 will divide by the question. So first write the a sub n plus 1 term. So n plus 1 by power n times 5 divide by, yes, it's okay, you can take 1 plus 5 and with ln with the argument n plus 2. Now this will divide by the question. So we change divide to multiply, it will flip, becomes reciprocal, please. So this one should be now multiply the question, now will flip, becomes 2n plus 3, it goes up. ln with the argument n plus 1 and divide by this one comes down, which is n times 5 power n. And don't forget, it has absolute values, right?
Yes.
I just put the, values in the basically a formula, okay? Okay. Now, let's check, is there any cancellation
Yes, five n, five power n.
Okay, so 5 power n and 5 power. Any other cancellation possible?
And
Yeah, no. There is no more cancellation possible, so it means that you have to calculate limits, okay? Before to calculate the limit, try to, collect the, functions, okay? So in numerator, we have 5. Okay, 5 you can take outside. It's fine, no problem. So 5 we can take outside, please. So now, because the constant, now we have limit. Okay, anything in the denominator as a constant? No. So limit and to infinity, please. Now, in the numerator, you have n plus 1. And what is that?
2
2n plus 1 and then ln. Okay. Basically, you can see that n plus 1, 2n plus 1, 2n plus 3, they are one type of function. Polynomials, we can say. Then you have natural log function, okay? So look at here. And similarly, in the denominator, look at here. We have n and 2n plus 5, and we have natural log function. So it's very clear in your, in your calculation, you have two types of function. One of them is natural log. The other is a polynomial function. So we can write them together. Means that these functions can be write separately. Means natural log function separate and polynomial function separately. So look at here. This is n plus 1 times, what is that?
2n plus 3.
2n plus 3 and divide by
2n plus 5.
2n plus 5
N plus 4.
and it is n. So what I did, I separate up function, we get a polynomial, and down function also polynomial separately. Multiply, now check, in the numerator, do you have natural log function?
Yes.
What is that?
And
And then with the argument how much? N plus 1. And in the denominator, please, ln with the argument how much? N plus 2. Understand right? Okay. You know why I did this thing? Minus. Huh? No, why? See, I did not do anything. I arrange. I arrange, polynomial function multiply log function means I didn't do anything change. I just write in a form, in a way, okay? Because they are multiplying, you can write in any form. Don't worry. But I'm asking why I am doing like that.
Maybe power. We look at power since it's infinity.
Yeah, any answer? Why I did this arrangement? Basically, limit has a property. If you have two different functions who are multiplying or even divide, limit can go to them separately. Means
So limits for the polynomial and limits for the
natural log.
natural log.
Yeah, maybe you are aware of that. So limit x approaches to any point here. If you have f of x and times g of x, okay? So we can write this one. For example, if it is two different functions are multiplying, and we have limit on that. So please you can write like that. Limit x approaches to that point f of x multiply limit x approaches to that point g of x. So you can apply limits separate of them without any problem. It's a property of the limit. Same thing we can do here. Same thing you can do here. Means here is 5. Now limit n approaches to infinity, please. Here we write. Okay. Okay, first I write here. Otherwise, it's very clear what's the answer here.
1.
Because if you multiply these two, what's the degree?
Square.
Square. And down
Square. 2n square.
square. So basically, you only get the coefficients. So 2 cancel means if you apply limit on that, so this will become basically 1. Yes or no?
Yeah.
So if you are, already familiar that the answer of the limit on this portion is 1, so no need to do this step, is fine. Go now, next please. Okay, I will write this step. 2n plus 5 times n. Then also limit n approaches to infinity, and then with the argument n plus 1.
We should write the 5 outside also, yes.
Yes, so, and now we have 5.
Oh, I
Correct.
just. No, separate.
Okay, now. So as you all discussed, it means the answer of this one on infinity, how much?
One.
Is 1, because when you expand, you get the degree, highest degree 2. So up, down, degree is same. We can use shortcut. So take coefficients. So coefficient is 2 here, 2 here, cancel is 1. Okay, so basically here is 1 times. Okay. Now, how you evaluate limit of this function, please? L'Hopital rule. This is infinity over infinity case. L'Hopital rule. So derivative of numerator and the derivative of denominator. So what is in the numerator? N plus 1. What is its derivative?
1 over n plus 1.
1 n, which is n plus 1 times n plus 1 derivative, which is 1. Okay, good. Divide by. Same thing here.
1 over
Same
n
thing
plus n
in
plus 1.
denominator. So 1 over argument, and of course times 1. Yes, you are right. Now this divide change to multiply, so it flip. It becomes n plus 2 over n plus 1.
Just remove the line,
Oh, we don't remove. Basically the derivative. What is Lnx derivative? 1 over x. 1 over argument. Okay.
So why do you just use fine?
Why?
Why do you use fine?
We in the formula we have full value. Check. Okay. In the rule it has absolute value. So we do not put our side. Okay. So now 5. I'm sorry. Limit is here. Okay. Limit. And approaches to infinity. Okay. So please just simplify. So it becomes reciprocal. It becomes limit. I'm sorry. Limit n approaches to infinity becomes n plus 2 over n plus 1 with absolute value. Okay, yes. Now you shortcut this. Up degree how much?
1.
Down.
1.
And limit is on infinity. So answer 1. So basically, and 1 absolute value. 1 absolute value. So what's the answer?
5.
5. Is greater than 1.
Divergence.
Oh, yes. As per ratio test, it is divergence. I hope you understand. Clear? So the last class we discussed factorials, factorials, please. Factorials, please. Question factorial is very important, by the way. So you have to focus more on factorial, how we evolve, we evaluate. Yeah,
Process imperfection.
Doctor, for example, how will you give us the formulas? Will you give us the formulas?
no formula.
No formulas?
No. Calculus 1, calculus 2, no formulas. Even 7, chapter 7 means why, I don't know why they allow chapter 7. I don't know, otherwise before it was no formula at all. So please, no formula sheet, please. Don't expect anything, please, on the formula side. Okay, so this is a ratio. So please, there are a few questions here, not many. You can just try this question based on this ratio test. In the last class, I think I answered 7. This factorial. Okay. Can you try third question? Because it has factorial also. Please check. Third question, please. Please check this third 3. Sorry. Number 3. Question 3. This is n minus 1 factorial divided by n plus 1 power 2.
We already did it.
We are done? Oh, okay, then it's okay. So means you have the idea of fact. It means I answered 3 and 7 already.
Yes.
Okay, good.
Now.
Now, okay, nice. So ratio test we have done. Now in 9.5, we have one more test. which is called root test. Which test? Root. As I mentioned already many times, that in exam it mentioned that you use ratio test, you use root test, you use integral test, use direct comparison test, use limit comparison test. Okay, so the method name is mentioned, please. So do not deviate from that, please. Okay, now a root test now, root test. Same, section 9.5. And the test name is the root test, please. Root test. Please try to understand, every test calculation is different. But there are some tests whose rules are same. For example, the ratio and root, their rules are same. Means if the answer of the calculation less than one converge, more than one diverge. Same here. In the root test also same. If the calculation answer greater than one divert, less than one converge. However, calculation is different. So ratio test, the calculation was a sub n plus 1 divided by a sub n. Okay, and we apply limits on infinity, and it has also has absolute. Clear? In the ratio test, the calculation is, please look at the calculation first. Limit n approaches to infinity. So if we have a sequence a sub n, please calculate, because what is that? Root. So basically, we calculate its which root? Which root? No, which root? When you say root, so it is which root? One by it is nth root. We are calculating which root? Nth root. If it is 3, is which root? Cubic root. Yeah. Third root. Yes. Okay. So this is which root? Fifth root. Fifth root. Which root now? And that's root, yeah. And calculate absolute value. So basically, we have to calculate the nth root of the question. Clear? This is the calculation of root. Now, if this calculation answer is what? Less than 1, so this series converges. Actually, the rule is same, like a ratio. Same like a ratio. Greater than 1, so series diverge. And that's all. Actually, we call it if absolutely, absolutely converges and absolutely diverges. Okay? So this is absolute convergence and absolute divergence. Because we have absolute values, okay? And same, if equal to 1, inconclusive. Equal to 1 doesn't work anymore. Okay, change the method. Equal to 1 means we don't know the series converge or diverge. So this is basically calculation. But before I go for a question, I will share with you a result, because this result really helps you, in the root test. So please note down this result. Limit n approaches to infinity, n raised to power 1 by n. The nth root of n, if limit is on infinity, basically it's what? 1. So please note down this result. Sorry? Is a property, yes. And it really helps. Means you can easily get the answer. So no need for further calculation. So whenever you have nth power 1 by n, so you can get the answer 1. It also works, let's say, if it's like that. Even if you have like that, please. Even if you had some constant plus or minus like that, it also works, with 1. And you can check because you have the calculators. So if you and approaches to infinity means very, very big value. So if you take here, let's say take here 10 power 5 plus 1, then the raised to power 1 over 10 power 5. Please check. How much you getting? Sorry, yes, please.
In this case, it's n to power 1 over infinity. Yeah, the limit is infinity. So 1 over infinity is 0. N power 0. How 0 to the power 0.
Please, this is in different form. Let us 7.5, please. You cannot do like that. You have to apply the local rule. The powers in different powers. Yes or no? Infinity power 0. Infinity power 0, one of 7 forms we discussed. 4 in the normal way, 3 powers, please. Infinity power 0, infinity 1 power infinity. Okay. This is one of the forms. So deal with that nominal rule calculation. Do you understand my point?
Yes.
So anyway, means you can check, please. I'm asking now. Check, please.
Yes, we got to.
And you have one? Yeah. So it means if even this n has some constant as addition, okay, +1, -1, it have so it also works for that. So you can use these direct properties to save time.
But for any constant.
Yeah, exactly.
As long as there is a.
Yes.
And not to be separated, right?
Sorry.
The end can't have constant options.
Yeah, means they should have a power, combined power as 1 by n. Here, I don't know, I just add in n one constant. Yeah, that's it, please.
Doctor, what if the n had a constant multiplied by 3n? Take it outside.
Actually, in that case, also, for example, you have, I don't think so if you have some multiplier here, so it really effective, you can check. I think still one. Yeah. Because this most one things will not affect infinity. Infinity is very, very big number. Okay? So I just share you some shortcuts, please, so you can use this property directly. Okay, so it means you can avoid some heavy calculations. Yes, please.
So when we would have the.
Why we have? Sorry?
We would have the.
Where is 0?
No, when it would be equal to 0.
No, please, I'm just using with you, please. If you have during your calculation, if you interact with this situation, please.
One.
Yes. So you can write the answer directly 1. Otherwise, you need some calculation. You have to prove why it's 1. And I told you this is the 7.5. Okay. So no need to go back and use all these calculation. Just write in mind and use the property.
But the first should be made as a forward.
Yes. So you have this property. Even I told you, even if you have this situation, means this n has some even multiply some constant or addition some constant if it has 1 by n power and n or infinity is also 1. Okay? Get the idea, please?
Yes.
Okay. Now let's start some question. So here, now they can ask you, please use a root test now. Root test. Okay. Let's start with number 9. 1 to infinity is the, and value sigma 7 divided by 2n plus 5 power n. So number 9 is 9. Now you're using a root test. So look at the calculation, please. You have to take the nth root of the question and apply limits n to infinity, and then you also have absolute value, please. Okay, so question number 9. Question 9. Sigma n is equal to 1 to infinity. 7 divided by 2n plus 1.
No, plus 5.
12 plus 5 raised to power 3. Okay, so please by root test, by using root test, please. Now you have to use the root test, please. Okay. So we know very well that what is the calculation of the root test. Basically, we have to calculate now the nth root of the question. So apply the root test limit. Limit n approaches to infinity. 7 divided by 2n plus 5, it has n. Now please apply here. Nth root. Actually, in the book, please, let me show you. In the book, they are writing the nth root like that. Like that, okay? The same thing, yeah. So because during the calculation, we have to change this as 1 by n. So that's why I did not give you this form, okay? So don't confuse, please. It's same thing basically. So calculate its nth root and it has absolute value. I just put the, work in the formula, okay? Now, because we are calculating the nth root of the question has two parts, numerator and denominator. So this nth root will apply on numerator, also this nth root will apply on the denominator. So now limit n approaches to infinity. So 7 has root how much? 1 over n, nth root. And then also the denominator, which is 12 plus 5. 2n plus 5 power n. Now also calculate its nth root and it has absolute value. You understand? I apply the separately in the numerator and denominator the nth root. Is okay?
So,
Now, yeah, of course, it is cancel out, please. And now, apply limits. Wherever you have n replaced by infinity. So what will happen in numerator? 1. 1 or infinity how much? 0. Divide by 2 times n basically. What is that? N how much? Yeah, so basically infinity. So 1 over infinity. What's the answer? 0. Less than 1? So what is the decision? Converges.
Doctor, can you repeat how it became infinity?
This one?
Yes.
Because 2 times n is infinity, so 2 times infinity. Plus 5. 5.
Infinity plus 5?
Infinity. That's right. You understand, please? Good.
Doctor?
Yeah.
You said that it was n to the power 1 over n. Should it be 1
Where?
or it's
Yeah.
that?
No, please, actually, you are applying, all the means in the question basically. So we have calculated already cancelled because we have to apply first and root.
7 1 over n should, it's not n?
No, 7 is a constant, not n. It's n. The variable, then it has 1 over n as a variable, then n is 7, not n. Is.
Doctor, any number over infinity is equal to 0.
Yeah, exactly. Means if even means if upper degree is less than down, and you are working on infinities, it means the down part is more dominant, more big. So if up is small, down is more big. Answer is what?
Down.
What's the answer? If upper is small degree, down is big degree, and you're on infinity.
0.
Huh? Yeah, 0 exactly. Okay. That's why it means. If you remember in chapter 7, 7.5, when we check the log behavior, in the argument, it was, up was degree 1, down this degree 2. So in that case, it becoming 0, understand? Yeah. Okay, let's take one more question, please. Okay, you can try. I think 10 is very easy. Because when you apply here, nth root is cancelled. Here, nth root it is cancelled. So it becomes 4 over infinity, which is 0. It's okay, good. I'm sorry? Factorial don't use root test, please. No. Factorial is for which test? Ratio. Good question you asked. Please don't try, for ratio root, please.
Because nth power of the, factorial no means it's very complicated. Please, huh? Because it's a good question. Actually, there is one topic that we have like next 9.7. 9.7 basically, we have a topic where we have a choice between these two tests, ratio and root. In 9.7, the topic is like that. Means we start with with any one test. Either you can use ratio or you can use root. So please, what is the best way? If in the question factorials are involved, please use ratio test. And if factorials are involved, so root is much easier. Means root test give you answer more in less steps. Okay, so this is basically comparison when we start. Okay, so I think it's better to go to 12th question basically because I think here, you try 11, please, then we go to 12. Please, 11 you can try. 4n plus 3 divided by 3n minus 5 power n. So please try this question 11, please. Come on, 11. Yeah, 11, please. 11. So what do you think? What's the answer? 4 or 3. Converse diverge.
Is
Greater than or equal to.
So diverge. Yes, you're right. If you apply here, root test. So limit and approaches to infinity. And it's 4n plus 3 divided by 3n minus 5. It has n powers. Now, please apply here. Root test means we need its nth root.
Then you cancel that.
And absolutely. So apply nth root on the question. So this n is cancelled out. Now we have to apply its limits for infinity. So you can use shortcut. Because up degree and down degree are same, so we have to take only coefficients. So in the numerator was a leading coefficient 4, and the denominator 3. Absolute value is same. 4 by 3 is greater than 1. This implies that diagonal is yes. This implies that it's diagonal. I hope you understand. Clear?
Doctor,
Yes, please.
what is the use of the absolute value?
Actually, the answer is always positive because, okay, good question. Basically, root test and ratio test, actually, the condition is that the function must be positive. So that's why to make that function always positive, we apply the absolute value. Is basically required in the formula. We do not apply from our sides, no. The rule which is given to us in the book, it has absolute value. We are not applying from our side of this. Okay. Now let's start 12 question. Please let me try 12. Sigma 1 to infinity, please. Question number 12. Now we are going for that. Question 12. Question 12. Sigma n is equal to 1 infinity. What we have minus ln argument e square plus 1 billion. So minus ln with the argument e square.
1 over n.
Okay.
The whole function is to the power n plus 1.
N plus 1. Okay, good. Now we have to calculate that, check that we converge or diverge by which test? Yes. So it's mentioned, means we have to use. So whatever mentioned in the exam, please follow only that procedure. So we have to use the root. Okay. So root test required the nth root. So please go ahead. Limit n approaches to infinity and it's minus ln with the argument e squared plus 1 by n, and the complete function has power n plus 1. Now we are applying here root test means 1 by n means nth root. Now we are calculating on the question with absolute value. Understand, please? We just apply the formula, okay? Right, now, what do you think? What should the next step, please?
Separate the position.
N plus one.
Any other suggestion? Separate n plus 1, how? What is other way?
N plus one.
Yeah, you cannot, break, no need for that. It's-
Can you add one the end?
Multiply the powers.
Yeah, so,
N plus one.
yeah, basically, you have exponent, further exponent, power again power. What happened? Product. Means if you have x squared and it has power 3, so what's the answer? 6 or 5? 6. Product. Exponent, further exponent basically is product. Same thing apply. N plus 1, then again 1 by n, they are basically, power and again power. So they will become multiply. So how much n plus 1 times 1 by n?
N
plus one over.
N plus 1 over? Okay, very good. So next time is that this power becomes product. So you get this one. Limit. N up to infinity, this is minus ln with the argument e squared plus 1 by n. And look at here now. The powers will combine, it becomes n plus 1 over n, and they have absolute value. Understand from here to here? We just make the powers multiply this. Same like I give example. X squared and power 3, so power becomes product. Clear? Okay.
Now you can split.
Sorry.
Now you can split.
What we can separate?
And over here.
Yes, we can break the powers. We can break the powers, exactly. Okay, you can do one more thing here. You can do one more thing here. Of course, we can break the power, but before that, we can.
Actually, by the negative text that.
Distribute and cancel the limit.
We can.
Cancel.
But
The power equals one is this.
Huh?
The power equals one because the limit is infinity.
no, it's a log function, please. It's an element. The log is a natural log. Actually, yes, you're right. Basically, you can immediately remove the negative sign. No need for that. Why? Because of solution. So negative sign you can immediate because it has absolute value. And this benefit for the absolute value. Okay. Is that right? I remove, get rid of this negative sign because of the absolute. Okay, good.
And one plus one over n equals one. Because the limit.
No, please, it's not n, it is ln, this natural log function, please.
Oh,
Come on, please. This is not n, this is ln, then we have e.
no, it's saying for the.
We have natural log here, please.
It's saying
The power equals
one above. The power, with the power above.
Yeah, wait, n over n, how much?
One.
1, and plus 1 by?
One.
Yes, now we can do like that. Limit. N up to infinity, please. Now we have strict value here. It's ln e squared plus 1 by, and now this function now. N over n, how much? 1, and plus 1 by? 1 by? And I break
Victor, we should keep that.
this over this plus 1 over this.
N over N is one.
You should keep the absolute.
Of course, we have absolute value here in the formula.
Even though the negative sign is cancelled.
See, if two function multiplying, so you can take absolute value of both of them. So minus 1 absolute value is 1, and we have one more function here, please. Okay?
Doctor, is N over N one equal to?
And cancel.
Oh,
Yes or no? Understand or no, please? N plus 1 over n, we can write n by n over 1 by n is a cancel. So I have 1 plus 1 by n. Understand? Yes or no, please? So that's what I have here. Okay, now next, please. Now, do one thing. Apply limits. Wherever you have n replaced by infinity, and check what is the output. Okay, sorry, limits we have mine, okay, no need for that, okay. Yes, please, this is ln in the argument e square plus, this n is infinity, 1 by infinity, how much?
0.
Okay, 1 plus
0, 1.
1 plus 1 by infinity, how much?
0.
So 1 plus 0,
1.
1, so here is basically this one, and it has absolute value. Sorry, so from here to here, you're gonna see. 1 over n is basically 0. Sorry, yes, because n is infinity. So constant divided by infinity is 0. Understand? Understanding is of these. Okay. E squared plus 0, how much?
Square.
E squared. Okay. E squared. Okay. The argument has power. So what does it mean?
2 and then 8.
2 and then 3. Okay, good. And then how much?
1.
1. So what do you have answer, please? 2. Absolute value. Whose answer? 2. Decide.
It's
Greater than 1.
So it is bigger than 1. So this implies that this is diagonal. Do you understand or no? Clear? So please, this is a way to set out how you apply the test on this question. Okay. Let's take one last question from this topic, then we go for further test, please. Again, please, as you mentioned, this lady mentioned in the 9.3, it is not the case that in 9.5 all the question can be answered by ratio or no, please, they're a mixture basically. Okay. Maybe some question can be answered by another topic. Yeah, it's quite possible, please. Okay. Let's try 18th question, please. Can you try please 18th question by the root test, please? Root test. 18th question. Please try, please. Come on. Yeah, please try 18th question, please. By root test.
With negative 1 to the power and 2.
No, everything is good. Please.
This is just for the signs.
No, this. When this we use when we go for geometric series, please. Otherwise, here you have to keep with you, please. So you have to calculate the nth root of the question, please. And it has 1, 2, 3, it has 3 components. Each component will take the nth root.
Oh.
Okay. Okay, good. It is less than 1, more than 1. Less than 1. So converges. Nice. Good. Yes, please. What answer you got? And I think you use the property. That problem which I told you. It will you answer 1, right? Yes, what's the answer of 18%, please?
1 minus 1.
1 by 8. Yes, good. So the answer of the 18% is 1 over E. Exactly. Yes, any other answer? Same answer, 1 over 8. So actually, as I told you, we are using here basically the root test. So root test means you have to calculate here the nth root of the question. This is a sequence, and we have to calculate nth root with what? With absolute value. Okay, and we have limit n approaches to infinity, right? This is the root of the root test. Now, because 1, 2, 3, I have 3 terms. Every term will take and yeah. So this -1 raised to power n, it has another root. Then I have n squared. It will take 1 by n. Then I have e power minus n. It will take another root. Understand, please? So in that case, every term will take the nth root, please. Take also 1 by nth root.
No, and.
So you can see that this and cancel out, this and cancel out. Negative one you can immediately ignore. Why? It has absolute. Yeah, please.
How does it cancel out the marks?
What's the problem?
It's
Minus
outside.
1 times 1 by n. This product you can cancel.
-1.
Negative 2 times half. Yes or no? So now this is gone because it is in absolute value, is gone, right?
Yes.
Okay. 2 times 1 by n. How much?
2, n power 2 over m.
N power 2 over
And
n. And here now what you have?
e power -1.
Okay. And here's the limit. Okay. And that which is 2 infinity. Understand?
Doctor, you can't cancel the 2 with n squared of 1. You can have n and 1 in the bottom.
Here?
Yeah.
2 times 1 by n, how much? 2 by n. 2 and 1 by n becomes the multiply.
Yeah, I know, but you can't cancel it. You can't cancel 1 n.
To whom I can cancel? See, this is power and this is power, and then multiplying. Means 2 multiply 1 by n is 2 over n. Okay? Right. Now, e power minus 1 is constant now. It has no end. So when you apply limit on infinity, it doesn't affect. Yes or no? Okay. I just shared with you one property. If you have n, then constant over n.
-1.
Limit on infinity, yes. So you go what?
1.
1. So this portion become what?
1.
1. Basically, you have e raised to power -1 with absolute value. E power -1 can be right 1
1
over
over e. That's less
and
than
1 over e answer, you can check, it is
less than 1.
less than 1. So if the calculation of root test is less than 1, it is convergent. That's why the answer of this question is convergent, is exact.
19 and 20 can do it with the root with the right.
Sorry,
Can't do 19 and 20 with the root with the right.
20?
Yeah.
Yeah, it has factorial, you can apply. Root number, but even I'm not sure, means it gives the answer not. I'm not sure about that. Okay, but don't apply here. Wherever you have factorial, don't apply root test.
So ratio test.
Ratio test better, yeah. But even is not a guarantee you get the answer, okay? But quite possible to get the answer with the ratio test. So here, please, is 1 by e, which is less than 1. So it means it is what?
Convergent.
Convergent. Now, please tell me, do you understand? All of you? Yes, please.
We have an absolute value. Have something inside it, and the power is negative. It will remain.
Power not change with the absolute. No, no, please. The multiplier change, not the exponent. Multiply something multiply with this number, then okay, multiply. That's a -3 times e power. Okay, so this minus sign with power, no, absolutely very don't change the power sign, please. Okay,
Yes.
I think we should go one more question, please.
Try 20 or no?
Sorry,
Can we try 20 or no?
20.
Yeah.
Okay, apply here ratio, please. Come on. Please, 20 question, please try with the ratio test. Okay, ratio, don't apply root. Ratio test, please. 20th question, please answer with ratio test, please. And factorial, divide by 10 power n. We're using which test here? Ratio. So for ratio, you need a sub n plus 1 term. Okay. So we are now doing number 20. So we need a sub n plus 1 term for that. Become n plus 1 factorial
Over 10 to the
divide
power
by 10 power n plus 1. Yes, good.
Then you divide it by the question and it should flip.
We divide the question and it flip. Yes, you're right. So it become what?
10
N
n over n
Power n over
and factorial.
n factorial. Very good. So basically, here you have now applied the ratio test. We make the, a sub n plus 1 divide a sub n. So now it's time to simplify it first so that we can cancel out some, required stuff. Please. Okay. This is n plus 1 factorial. This is n factorial. So who will go back to cancel?
This one.
N plus 1. What is the, we factorial take it back.
Yeah.
So after n plus 1, what is next?
And
N. Yes, one step back. So n plus 1 factorial, you can write
n plus
n
1.
plus 1, then n and stop here and put factorial. Divide by. Can I break 10 power n plus like
Yes, 10 to
10
the
power
power of n
n?
and 10 to the power of 1. We can take 10
Yes.
outside.
Here 10 power n here, divide by here and factorial, absolute value, please. Also limit here and up to infinity. Okay, now any cancellation.
Yes, and factorial.
So this cancel, this cancel, sorry.
Down, is one.
Good. No, we are applying on 20th question, the ratio test. Ratio test formula has infinity.
See the question?
No, we are using the rule, please, okay?
We can take 10 outside.
Okay, so now after this cancellation, 10 is in denominator, you can take outside, we have now 1 over 10. And we have now limit, and that's what this to infinity is n plus 1. And definitely the answer is what?
Infinity.
Which is basically, if any calculation give infinity, it is divergence. Yes, this is divergence. Divergence. So my friend understand this divergence because when you apply limit infinity, I have n plus 1. The n take infinity, infinity plus 1 divide by 10 is infinity. So divergence clear? Good. Yes, please.
Can you please repeat the factorial part?
Factorial part?
Yes.
We already discussed that factorial takes you back.
Once,
So n plus 1, next term. The one number please minus. So n plus 1 minus 1
then
and
that's why we wrote the n.
exactly. Please expand factorials, okay? So we go back, one step back.
So it was n plus 2.
So n plus 2, n plus 1, then n,
And
yes, then, no, one more back from n minus 1. Then n minus, yeah, so just subtract minus 1, minus 1, minus 1, 1. Subtract minus 1, minus 1, minus 1 to go back.
and then we put the.
We actually, we have to check what is my question. This question will tell you how much you had to expand. For example, means I can give example here. Let's say in your question, please. Here you have n plus 2 factorial, and here you have n, let's say minus 1 factorial. So how much you expand? Okay, you expand n minus 1 to reach n plus 2, or you?
No, I expand.
Yeah, the big one is basically go close. So n plus 2 factorial, you have to open until n minus 1. So start now. N plus 2, next.
N plus.
N plus 1, next.
And
And next.
minus
Now switch to your required thing. So stop here. When you stop here, put here.
Factorial.
It's called a hazard sign, okay? And divide by here, n minus 1, and six.
now we can cancel.
Now we can cancel. I hope you get the idea. Good, okay. Okay, any more question we can discuss, otherwise we start on next topic, please. So. Oh, okay. Yeah, here, this is a good question, we can talk about that. Okay, so. I think 14 questions is quite easy, basically. Sine has power how much? And when you apply the nth root, n will cancel. Now your limit is n approaches what? Infinity. 1 over infinity.
Zero.
Zero. And sine zero.
Zero.
Do you understand what I did? Look at it, please look at here, means here. Here, apply here, please, nth root, understand? This cancel out, yes or no? Limit is on what? Limit n approaches to infinity, sine with the angle 1 over n, please, okay. Apply limits.
Sine 1 over 0.
Sine 1 over infinity. So 1 over infinity, how much?
0.
0. Sine is how much?
0.
So decide.
Less than 1.
Less than one. Convert.
So convert this. Hope you understand. Get the idea, so no? Come on, tell me, please. Okay. Please try 16. Please try 16 by root test, please. Come on, let's start this one, please. 16, please. Then shall I will reduce the. Sorry? I understand. You are what? Please, 16 question. Apply root test. Root test. Then I have to start 96.
We can this week. Will we finish the calendar this week or will we have one day?
No, we have one more class. Next class we can.
Next class or next Thursday?
Next we have exam. So see last week.
Okay, you have Thursday.
This week the last. So inshallah we finish this week. The next exam. Again you are studying. So please apply your root test and let me know your decision.
We apply separately up and down.
Of course, because you have numerator and denominator, so it's better to apply the nth root up and down. Yeah. You are 0, so 0 means less than 1 answers. Convert. Yeah. I think yeah, you Oh, of course, I make examination.
No, you make it or still you do it?
No.
Doctor, I know you have good, give us.
Yes, please. What's the answer? 16th question. 0. So less than 1 it is convert. Yeah. You're right. Basically it is coming 0. You're right. Do same thing. You have to apply here a root test. So please calculate nth root 1 by n. So this nth root will apply numerator. Also apply denominator. You're right. Up is basically cancel out. However, 1 plus n and 1 by n will multiply. So basically, this is absolutely right. So minus is gone. You have 1 over n raised to power 1 plus n over n. Because 1 plus n times 1 by n is this one. Okay? And now, break it. N power 1 by n by n plus 1. Now, yes, it's better to break exactly. So this 1 over n, 1 by n plus 1, you can split, yes. So please look at it. 1 divided by. Please, how you write in two parts?
N power 1 over n.
N power 1 over n times n power 1, which is no need to be quite, okay?
Yes.
Now, because our limit is on infinity,
Yeah.
limit is basically,
The n to the power 1 over n equals to 1.
yes.
Equal to 0.
This one, you know very well, this part on infinity is
1.
1. I shared the property already. This n replaced by infinity, so 1 on infinity is 0. So finally, the answer is 0, which is less than 1. It is converges. Less than 1 converges. Okay, greater than 1 diverges. Hope you understand? Very good. Okay, it's all about 9.5. Two test ratio and two. Calculations different, but the rules are same. Okay? Now, 9.6. No, 9.6. It is fine. Exercise number 9.6, please. And we have one more test, which is called AST, alternating series test. Alternating series test. In short, we say AST.
Doctor,
Yes, please.
And the homework, there is no questions on.
9 point? This one? So the problem, learn it. And it's very easy, by the way. It's not any more calculation.
Doctor,
Yes, please, please.
chapter 9, we will study until 9.9.
9.8.
Yeah.
Alternating series test. Okay, how it works? What is the rules and calculation, please? If you look at the name, alternating series, and I told you already which series are called alternating. Yeah, whose sign different, positive, negative, positive, negative. And how do you understand in the question? That the question is alternating series, how? Minus 1 power n, or if you have minus 1 power n plus 1, is understood this series is alternating. Okay, one thing is confirmed. This test only and only valid on alternating series. Please don't try this test on other series. If series is alternating, then you can apply this test. But same time, it doesn't mean every alternating series can be answered by this one. No, please. But this test only applicable on this series alternating. And I told you already how you identify the question series is alternating, yes or no.
Yes.
Either you have this component in the question or you have this curve. Any one of them available in the question, confirm series is alternating. Okay? Then you can apply this test. But it's not guaranteed that this test will answer the question. Okay? No. But this test only and only applicable in the alternating series. Understand? So this is the some information about alternating series. Let's check, let's discuss how this test works, please. Okay, to apply this test, basically, we have to perform two calculations. How many? Two calculations. Calculation number 1, please. Limit n approaches to infinity, a sub n should be equal to 0. The answer of the first condition should be what? 0. Means this this test has to justify two conditions. Number 1, the calculation of the sequence or infinity, the answer must be 0. Okay, if it is not 0, then
No answer.
if the first condition not justify, for example, when you make calculation, it is not 0.
No.
We cannot choose.
Then,
Cannot choose.
yeah, we not, but no. Actually, it's very interesting. If the first condition of the ASD not true, like here, not 0, immediately series diverge. Okay, please, note down. If in the alternating series test, the first condition not justify means the answer is not 0. This calculation answer not 0. So immediately series diverges. No more calculation required because we have decided about the series is diverges. Okay, but please, for the ASD, the first condition is that The answer must be 0. Now, number 2. The second condition is that the series, this sequence A sub n must be, what is that? What is that? No, no. Decreasing. If these two conditions justify, what's the answer? Yes, the series converges. If both of them justify, then series, that ordinary series converges. Okay? So this implies that series converges. Series converges.
We do the first derivative test.
Oh, yes, good. And how to check decreasing?
First,
First derivative test. Yes, you are right. Hope you understand. The idea? Okay, I told you, this if first condition not true.
Diverges.
Yes, okay. Any other question?
But what if it wasn't decreasing?
Means if second condition not true, for example, first true, second not true, then inconclusive, yes. Then this test fails. Use any other method. Understand? However, if first condition not true, immediately write the answer diverges. And this is a blessing. If you get this not true, oh, answer get diverges. Okay? Anyway, let's take question, please. As I told you, perform these two calculations. Number 1, calculate the question on infinity, please. If answer 0, go to next condition. And here we have to perform the first derivative test, which we already did in which test, remember? In which test we use also decreasing condition. Don't forget in exam, you have marks of that step. It has 3 conditions for integral. Number 1, positive. Number 2, continuous. And number 3, decreasing. And decreasing, you need first derivative test. Also here you need first derivative. Okay? That's the question, please. Then we go for break. So it's not something very, you can say difficult test. Only these 2 conditions you have to justify. And of course, that's it. Let me just download some question on that. 9.6, please. Download. Okay. Right. Even if the outer series converges or diverges, and what is the sum of the series? Not the conditions of the. Okay, means they told it's quite possible these 2 cannot justify. Okay. Anyway, let's start some with question, please. For example, question 4, they can take 4. Huh? So by using alternating series test, check number 4 series is converge or diverge. By using this series, by using this test, AST, alternating series. Okay, my first question. Number 4 question, is it alternating?
Yeah.
Sure? Yeah, because if it is not alternating, don't try this test, please. And yes, we know very well, if you have -1 power n component or -1 power n plus 1 component, whenever the question confirm series is alternating, okay? Good. Okay, please write the question first. Number 4, 9.6, number 4. Question, please. Question number 4, 9.6. Number 4, please. Sigma
From n equal to
2 to infinity.
Yeah.
Okay.
Negative
-1 raised to power n. Okay.
times 4 over ln n squared.
And then n square. Good. Okay. What is first condition to check in ASD?
Alternating.
Huh?
Whether it's.
Please, we are use alternating series test. Okay. As I told you, in exam is mentioned. Okay. Right. I'm sorry. So what's the first condition?
Limit.
Limit. First condition, please. Limit n approaches to infinity a sub n. We have to calculate. Okay. Now, please, one more thing you have to be very careful. You apply these conditions, means first and second, only on the function. Don't apply on the sign controller. What is sign controller here?
Negative
One.
one.
Please, don't include in your calculation. No. We will perform all these two calculation on what?
The second one.
Oh, yes, please. Sign control will not into consideration. Do you understand this step?
Yes.
Yeah, please, be careful, okay? So, please, we have to find 4 divide by ln and it has power 2. Okay. Can I use here local rule? I'm asking. Can I use here local rule? Local rule possible here? Yes or no?
No.
No? Why no?
Yes.
Actually, local groups need two things, 0 by 0 or infinity by, both of them are not available here. So of course we cannot use. So simply apply limits. So ln infinity,
Zero.
Infinity.
okay, infinity square, okay, 4 by infinity.
Zero.
Yes, basically it is 0. So first can you justify? Yes or no? As per ASC, first can you justify? Very good. So now you can perform second condition. For example, if it is not 0, then yes, then it's very clear it is divergence series. But unfortunately, it is not like that. We have to perform second because first condition is okay. Right. What is second condition?
Increasing.
Decrease.
And for that, what we need? We need first derivative test. Very good. So now for the purpose of second condition, please,
Also,
we need f prime. My function is 4 ln and power minus 2. Yes or no?
also the derivative will be applied for the second function.
I told already, please. We perform the calculations only on the sign controller will not work. So please, for the sake of derivative, I took the function up, right? Because no need to use the quotient, no need for that, please. Okay, f prime, please. F prime. Okay. So 4 as it is, minus 2 ln n power minus 3 times. Oh, yes, times 1 by n. Okay, perform, oh, sorry, simplify one more step, please. So I have here negative 8 divided by ln n power 3 and n. Yes or no? Understand? Okay. This is my f prime, my simplified form. Now for the critical points,
You take the,
up 0, which is minus 8, not possible. And then denominator equal to 0. So in my denominator, I have two functions. Yes or no? So second please, ln n power 3 is equal to 0. And also n is equal to,
Zero.
okay, from this one.
Zero.
So,
It's not in the.
So immediately rejected. Why? Because your domain
It's
start
from
from
to infinity.
2. So n0 is not there. Now, second part here. So here basically, take 1 by 3 both sides, you get n and n is equal to 0, apply both sides e.
1.
So, sorry, n is equal to, yes, 1.
Which-
N is equal to e of 0, which is 1. Also rejected because start from 2.
What's the two?
Understand? What we did before?
Now we put from 2 to infinity and retest.
Yeah, you have to perform this. Put domain line. Domain from where to where?
From 2 to infinity.
2 to plus infinity.
We take.
So please, any test point?
Yes, 3.
3. Where you substitute?
First derivative.
Very good. First derivative. This is my first derivative. Check please. Put the test point in first derivative. Test point is like 3. Come on, give me the negative. So increasing, decreasing.
Decreasing.
Very good. So second condition justified? Yes or no? Okay. So first condition justify, second justify.
So
Then
convergence.
this series is
Convergence.
very nice. And that's all.
If it was increasing, what will it be?
Oh, this is inconclusive in that case. Series converges. My dear students, this is not sorry.
Constant and up.
So you have to check the decreasing interval is dominant or limited. Yeah,
You mean
So it's a decreasing interval is going to infinity. It means it's more dominant. So we accept the dominant behavior. So it's very clear. Positive behavior very limited means from this point to this point. But overall series is decreasing. Yes, means function is decreasing. Okay, hope you understand. Very good. Please, yes.
Sorry, we substitute the three.
First, that is it. The behavior increasing, decreasing,
And we go
Negative.
Negative, then let's see.
decreasing. So, get the idea? Okay. So I think, okay, you can try one more question, please. No problem. Because we have to take the, okay, three questions, please. Is it rotating series? Okay, so what's the function for you to perform?
1 over
1 over n, 3 power n. Please, you can go. So this three.
We don't use the sign controller at all.
Sign control we do not consider in the AST calculation. So actually now, if you just combine all the information, there are two series where we do not consider the sign controller. Where and where? In which two tests we do not consider sign controller?
the first.
The first one where we do not consider sign controller. Geometric series. In geometric we do not consider. Okay. We do not consider, but we make a decision. If you have a geometric series sign controller, it means R is, don't ignore it basically. If in the geometric series you have sign controller, it means R common ratio is negative.
But there is the absolute.
No, that is for checking the converge or divergence of. But when you make a sum of geometric, what
Yes, definitely.
A1 is first term divided by 1 minus R. So if in your geometric series question, you have sign controller, so your R is negative. Yes. Okay. And this is the second series here where we are not making any calculation on sign controller, which is AST, alternating series test. Clear? I think the first condition is very clear here.
Yes, this one.
Means this condition, the first condition, when you apply an infinity, so 1 over infinity is 0. Second condition, please check the derivative. Okay? Do you understand this?
Yeah.
So only two things we have to perform. I told you if first condition not true, immediately series diverges. No more calculation after that. Please stop. Because first condition of AST not justified, so it is divergent. That's it. We have got the answer. It is divergence. Okay. Because we only need that series converge or diverge. Please.
Here, the sign controller just indicates.
Just the indication to confirm that the question is alternating series. Yes. Get the idea? Okay. I think after break we go for 9.7, please. Which is slightly, we can only finish today 9.7. Next slide, inshallah, 9.8, we discuss. And then you should. Yeah, if you have some question, most welcome. Why not?
And for
Oh, yes, that's it. What is the next? Anything you have? So, what else you need?